And just stay put, because now we are heading straight for Christian Brown from Google to talk about Passkeys. And after that, we're also doing the panel on all things FIDO, where we have both FIDO Alliance, we have Microsoft, and we have Google up here. If you have any questions related to that, you can ask that while we go ahead with the panel discussion. You can tweet at me if you want on Twitter, and I will ask the question anonymously on your behalf. But prepare your questions for that. And while Christian is getting ready, I can do some of my old jokes, like my ex-wife is probably the woman in the world who knows most against her about passwords against her own will. A pin walks into a bar and the bartender says, "What?" You're too short to be here, obviously. Yeah. I have a little thing with Christian. I was doing PasswordsCon in Stockholm in 2018. I was incredibly happy to see that Christian from Google submitted the talk. He wanted to come and talk about FIDO stuff. And being the person I am, I was thinking about, well, so Christian is coming to talk about FIDO, and you know, I've been up and down talking about FIDO before as well. So I figured how to best welcome Christian to Scandinavia, to Stockholm and Sweden. So I created a t-shirt saying, what do we still have in 10 years from now? Passwords or WebAuthn? So we have a 10-year bet between the two of us. Loser buys a beer for the other one. What do we still have in 10 years from now? Christian, I'm really looking forward to hear about Passkeys, where we are and where we are going.
Fantastic, thank you. Let me see if I can make the lapel mic work. I like to walk around. And here we go. All right.
There we have some. Yep.
Perfect. Let's see if we can clip it on this one. Yeah. All right, let's do it like this. Do let me know if it slips down, and then we'll figure that out during the presentation. Thank you for the warm welcome, Per. I'm Christian. I'm a product manager at Google, and I've been working on FIDO and WebAuthn related initiatives for almost a decade now. This is the year, I feel like. I say that every year. No, this really is the year. And I think what I'm going to try and do here is go through a little bit of background on like what we've been doing. You know, I think the presentation is officially titled like, you know, where we are, where we've been, and where we're going. And then we'll lead into a Q&A with the panel where some of my other colleagues on the FIDO side will join me if folks have any questions, and we can have a healthy discussion. Before we get into that, though, I just want to make sure that I have my logistics figured out. I am planning to do a live demo, which is always a lot of fun, especially for the people in the audience when it doesn't work. So I think we're good. I think we've got everything ready, and when we get to that part of the presentation, hopefully we should be able to do that without too much trouble. I'm going to plug this in too. Just want to make sure. Don't want to set up my keyboard now. And hopefully we should be good to go. All right, excellent, cool. Can folks still hear me if I'm walking around here? No? Let me clip this on my t-shirt up here. See if that's better. Is that okay? Folks in the back? All right, excellent, great. Okay, so again, I'm Christian, and we're going to be talking a little bit about Passkeys today. So let's start with why we're doing this work, right? What is the reason why we got involved in this in the first place? Back in 2009, Google suffered an attack, very similar actually to what has happened just 2 or 3 days ago with some other vendors. Basically, Google got phished, right? There was a phishing email, phishing message, someone clicked on it, gave away credentials, and hey, you know, someone got into the system. And that same thing happened recently, and it still happens, and it really is because passwords are so incredibly easy to phish, right? It is so trivial in tricking a user into revealing their secret data, the thing that is supposed to make them unique. So easy for them to reveal that to, you know, some other source, And to be quite honest, it's much easier to set up a website and exploit phishing than it is to exploit, I guess the inherent protection in systems today that come as a result of malware protection, right? If we think back like a number of years ago, if you look at this graph, right? Back in 2012, 2013, 2014, the way that you would pop someone is by getting malware on their system. No one does that nowadays, right? For two reasons. Phishing is super easy to pull off, and secondly, operating systems have become much better at isolation and just in general at keeping bad and unwanted software out. Apple App Store is one way, very curated. Google Play Store, kind of similar. And even on other desktop operating systems, the operating systems have become much, much, much better at ensuring that bad software and unwanted software stays out. So phishing is the one thing that we want to protect against. Back to the short history here, 2009, this stuff happened, and we vowed that we don't want phishing and credential phishing to ever be a problem for Google enterprise users or Google internal users again. And that's really where our journey, the Google journey, started towards the stuff that I want to talk about here today, which is FIDO and Passkeys and WebAuthn. So we wanted to find a solution to this problem. So a bunch of different companies got together, right? This isn't an exhaustive list. This is a couple of names of folks that's part of this thing called the FIDO Alliance. And I'm sure folks in this audience have probably all heard about the FIDO Alliance. It's a bunch of us that came together and we said, hey, we want to solve this problem. We have this phishing problem. We have usability problems. We've got other problems. We want to, band together and we want to try and address this problem going forward. And what we came up with is something called, and in the next slide, you'll see a little bit of a different explanation of this, but we came up with something called WebAuthn, Web Authentication, and it's a W3C, World Wide Web Consortium specification, that allows developers or web developers to interact with security hardware and security implementations on platforms. And we'll talk a little bit more about what that means in a second. But basically, there's the World Wide Web Consortium who has the specification for a lot of this work. And then there is the FIDO Alliance, which is the organization in which a lot of us operate together and kind of like came up with some of the work that ultimately led to the specification in the W3C. And a different representation of how that works and how these things are related is this graphic here. Essentially, you have FIDO and FIDO2. FIDO2 is kind of like this overarching thing, this umbrella terminology that sits at the top. And then inside of FIDO2, you have a web specification, which is how a developer would interact with FIDO stuff. If you write a website, essentially you'll deal with whatever is in the W3C WebAuthn specification. That's kind of like on the right-hand side here. And then if you are a vendor that makes physical security keys, right? That's stuff that we'll talk about in a second. That's part of what we've done in FIDO. Physical security keys was the first instantiation of FIDO hardware and of the solution, this phishing-resistant solution, which we'll talk about. But essentially, if you're an authenticator vendor, then you deal with the standard that sits under the FIDO Alliance, which is called CTAP, Client to Authenticator Protocol. For most of us in this room, if you're not an authenticator vendor, if you're not interested in making physical keys, you can ignore most of the part on the left there. But what is way more interesting is recently, we've decided that not only will we, under the FIDO umbrella, be supporting physical external security keys, things that a user has to buy and carry and that they can use to authenticate, but we will also support built-in authenticators. So stuff that's already inside of the platform that can make the platform act and get all of the benefits of a FIDO authenticator. These are things like fingerprint sensors, the screen unlock of the device, face recognition. So there's a lot of this technology that has been in devices ever since the advent of the iPhone 5S, I guess, which is the first real consumer device with a fingerprint on it. I mean, before that, we had some desktop and laptop systems, but it never really took off. This is the first time that it became mainstream. And when we saw that, we were like, hey, it would be cool to allow developers to get access to that hardware with all of the features and all of the benefits that FIDO authentication provides. So we'll talk about that. So if we look at a quick timeline here, right, we started off with the physical removable security key. Back in 2009, when Google had our issues, when we said, hey, we never want to get phished again, we designed a protocol, which is basically what ended up becoming U2F, together with some other folks that work with us in FIDO. But U2F, Universal Second Factor, was the first instantiation of FIDO, and that is where you use a physical device. Most of the time, a USB device that has some key material on it. When you want to sign into a system, you present this key material, and then the way that the protocol is constructed, the authentication sequencing is phishing resistant. So it means even if you're tricked into going to a website that's not really the real Google or the real Microsoft or the real Facebook, the security key will not reveal its secret. And that was kind of like one of the big benefits of moving into this FIDO world, because if you look at other forms of multi-factor authentication, pretty much none of them, except for smart cards, have the inherent phishing protection that FIDO devices have. So FIDO devices brought, back in the blue kind of side on the left, it brought phishing-resistant multi-factor authentication to the masses and to the web. But we still needed users to go and buy physical security keys. And we knew that that had a very limited kind of like usable segment there. And then we went on and we said, well, it's really cool now that the iPhone 5 has fingerprint sensors and Android has fingerprint sensors, and now it has on laptops and other devices. We have like Windows Hello, which is a mechanism for doing biometrics on the device. What if we could tie that same technology into FIDO, and we can essentially expand from only users who buy physical keys to a world where anyone that has hardware that has these capabilities can also benefit from phishing-resistant FIDO as kind of like an additional factor. We'll talk about that in a second. So that's kind of like stuff that we've done back in 2017, 2018. Lately, we've added support for other purpose-built flows. For example, there are certain types of financial services regulation that came out in Europe. In the US, we see a lot of a specific type of credit card transaction security that's needed, stuff called 3D Secure. So we were working together with these other bodies, essentially, in saying, what can we do to take FIDO support that we have and bring it to more and more use cases? So not traditional authentication, but other types of specialized authentication flows as well, for example, payment flows. That was all great, but we still had a problem. We still have this adoption problem where FIDO was kind of like for a minority. FIDO was for users with physical security keys. FIDO was for users or developers who really added FIDO as an additional option over and above passwords, but it wasn't really closer to getting us rid of passwords completely. It was still one more option you could use. If you think back to the biometric authentication you have in your phone today, right? If you have a banking app on your phone, most of the time you open the banking app, you sign in with your username and your password, and then you upstep into biometric authentication. The next time you come back, now you can use your fingerprint. But the moment you buy a new device, you're back to password authentication. So you're never getting rid of passwords. You're really adding biometrics and adding capabilities in order to make authentication easier and more user-friendly, but you're not getting rid of the security downsides of having a password attached to that particular account. And that's really where Passkeys came in, which isn't really a different specification or a different technology. It is taking what we have in FIDO and WebAuthn and applying it in a certain way where we can actually finally start, hopefully, getting rid of passwords completely, and me winning that bet with Per and getting a bunch of beer. So let's talk a little bit about that in a second here. Security keys, the fob, this is the use case we had first, right? Users go, sign in somewhere, you type your username, you type your password, you pull out your security key, you plug it into the drive, and hey, you're magically authenticated. Not really a better user experience than using passwords. One can argue that it's maybe better than having to use SMS OTP in terms of usability, or better than having to use push because it's easy and the device is already maybe in your USB port and you just tap it. But it was definitely an improvement in security, but it wasn't really an improvement in usability, and it certainly didn't get us closer to getting rid of the usability issues regarding passwords. Platform authenticators is the thing we did next. As we can see here, we saw these things start to appear in more and more devices. Fingerprint sensor on laptops, phones, laptops there on the left-hand side in terms of the camera, facial recognition. And with that, we were able to build some interesting web experiences. And this is a GIF that should play. There we go. You should see this working here. This is, for example, you can see we're on a website, right? You're on accounts.google.com, and you're trying to do something where we need additional assurance that it's you. In the past, we would have asked you to enter your Google password. Here we say, just touch your fingerprint on the system and we'll authenticate you. Not really that groundbreaking, because apps were able to do this, since the iPhone 5S. But finally, with WebAuthn, we brought these experiences to the web. So we allowed web developers to also make use of the inherent technology built into these platforms. And we had a bunch of relying parties or developers supporting these flows. PayPal had some implementations, eBay had some, Yahoo Japan, Entity Docomo, and Google, and a bunch of others. So actually, I saw an email this morning, a colleague of mine sent me a screenshot of a Yahoo US account that actually has a similar functionality here as well. So now I can probably start removing the JP designator there under the Yahoo side, because it looks like we're still seeing more and more adoption of this type of workflow. But like I said, this is a usability improvement, right? It's not necessarily a security improvement. If your finger is wet, as Jim said earlier, you still get the fallback, right? You can cancel out of this flow and always opt for still typing your password. There is no reason why you can't go back to that. What we wanted with Fido, and ultimately with WebAuthn, is we wanted to move beyond the password. We want to end up with accounts that don't have passwords. They might not even have usernames. So the big question is, how do we get from here, which is where we were, into that world? And that's really what we'll be talking about here. So I had a problem with Fido adoption, as I said, right? Problem is usability, right? Limited consumer awareness and usage of security keys. I can tell you about the statistics there, but as you can imagine, it's not like we see all Google users using security keys. I mean, we can't even get all Google users to use USB. So, I mean, and there are certain types of initiatives and things that we have where we're trying to push more users to take more ownership of account security. But it's hard when that entails physically buying something and carrying yet another device. So we had that challenge. Second one is, challenges with platform authenticators is the second factor. Even as a first factor, like I said, we never got rid completely of the password. We just gave you another option. And it's great to have more options, but that doesn't really change the security paradigm or the security model all that much. And then the last one, as I said, like high barrier to adoption for users who need to opt into 2SV. I mean, we can't even get users to opt into 2SV. How do we opt them into using technology that entails an additional step or 2 or 3 steps, and having to carry around physical devices and all sorts of other stuff? So these were the problems, and these were really the Fido limits back before we started in this engaging in this passkey realm. So what is passkey? Well, passkey is a password replacement that is safer, easier, and faster to use. Passkey isn't the brand. It's not supposed to be capitalized. It's a noun. It's like passwords, right? You just say, hey, I have a password. I have a passkey. The idea here is that this is a word which the industry can kind of coalesce around. It's not an Apple brand. It's not a Google brand. It's not a Microsoft brand. It's not a Fido brand. It is just a passkey, which is very, very similar to a password. And hopefully in the user's mind, we can start to create this concept of yesterday I used passwords, today and tomorrow I'm going to be using a passkey. And we can start to essentially help users with the user journeys and the changes in user behavior that will be needed to support the transition to passkeys. And that's what we'll be talking about here for the next couple of minutes. So the capabilities that we get, and I stole these slides shamelessly from Andrew's deck. Thank you, Andrew. So the capabilities that you get in a passkey world, what is different from WebAuthn yesterday and Fido to passkeys today? Well, the first one is, remember that problem that I said, it's great if you have an app and you type in your username and your password and it upsteps you into biometrics, but the problem is tomorrow when you buy a new device, you're right back to typing your password again. Well, what if we can remove that restriction? What if we can give you a Fido key the moment that you register your biometric for a certain app? Let's say I open my Bank of America. Take an example. I open my Bank of America app on my phone. I open the Bank of America website on my phone or my laptop. I sign in with my credentials, username, password, and they give me a Fido key pair. I didn't go into that details. I'm assuming that folks here kind of like have a basic understanding of what's going on beneath, the layers of Fido. But essentially, when you get a Fido, when you do a Fido registration, when you register your security key, or when you register your platform authenticator, your fingerprint sensor, or your facial recognition on a certain website or to an app, a public-private key pair gets created. The private key stays on the device, and the public key goes to the website, right? So that's kind of like how Fido works. Back in the day, earlier on, Fido private keys were protected on the device only. When you have a physical security key, the private key is on the device. It stays there. When you register it on your phone or your laptop, the Fido private key stays on the laptop. What if that restriction didn't exist? What if we could take that private key that you have on your phone and we could replicate it to all your other devices that you own as well? Kind of almost like what a password manager does today, right? Password manager wouldn't be super useful if it only ever kept your password on one device and you couldn't get it off, right? Password manager is useful because your passwords are available wherever you need to use it. So what if we take that property and we apply it to Fido keys? So when you register a Fido key and you make a new Fido key for a service on your phone, we're able to take that Fido key and replicate it and bring it to other devices that you own as well. Now, of course, if you're a student here, you'll immediately say, well, how do we know you own those other devices? What if it's an attacker? And that's the type of thing that we want to get to later in our panel session. But essentially, if we're able to know that you own 2 or 3 other devices, let's just proactively go and put your FIDO keys on there as well. What that means and what that looks like is when you move and you buy a new device, you go buy a new phone, you never have to fall back to typing a password ever again. You'll just continue to use your biometric, your face, your fingerprint, your screen unlock, and that gets you access into that particular service without ever having to fall back to passwords ever again. It's basically make FIDO as ubiquitous and available as passwords. There are some caveats to this, but we can get into that in the later session. The second thing is, well, what happens if you're on a device and you just don't have your FIDO credentials there? I mean, this is the typical password problem, right? The password manager problem. I think I heard earlier folks saying like, I have this issue where I want to sign in on my television, or I want to sign in on a friend's computer. I have to retype my password from my password manager into the keyboard at a special character. It's a huge pain in the ass. Like, how do we solve that problem? Well, the way that FIDO solves it is we developed a local protocol that allows 2 devices to talk to one another over local proximity using a specialized Bluetooth protocol. So essentially the use case is, I want to sign in on my television, I want to sign in on my friend's laptop, I go to their laptop, I click on the website I want to sign into, I bring my phone close enough together, which has my FIDO passkeys, close enough together to their machine, I tap the account I want to use, and magically I'm signed in. No retyping of credentials, totally phishing resistant, because everything that is FIDO related still stays intact, and my credential actually never goes to my friend's machine. Only the signature that allows a once-used sign-in actually goes to their machine over this local proximity protocol. Because it's not via the cloud, because it's local proximity-based, we get all of the inherent phishing protection that you get out of FIDO in this particular protocol as well. And these 2 things is basically the only difference between what we had in old FIDO and what we have in new passkeys. It's FIDO credentials with the ability to synchronize and the ability to be exercised remotely using these proximity protocols that we've now defined and that most popular operating systems have stated that they will adopt. So we have support for this, whether you're using Android to a Mac device or whether you're using an iPhone to a Windows device. These protocols are implemented in a standardized way so that it's not a vendor lock-in. It works basically essentially, well, it works, doesn't matter what platform you own. As long as it's a fairly modern platform, and again, we can talk about the exact versioning there, these types of experiences is what we enable. So, here's an experience on Windows, for example. User goes, want to sign in somewhere, sends a prompt to the phone. Again, it's not a prompt via the cloud. It's a prompt to the system on Android here. It's also not to an app. It's to the Android system, and it allows you to then unlock, in this case, using your face here, pick the account you want to use, and then over the local proximity protocol, we then let the device know that, yep, the user has authorized this login. They can go ahead and they can continue, down this track. Cross-device, cross-ecosystem, one mobile device can bootstrap another ecosystem or another device, which is essentially how we get away from the issue of having the user, retype long strings. And if you retype a long string, you can make an error and type it into a phishing website and whatever. None of that is in effect here because everything is essentially automated between these 2 systems, and there's a handshake. So access a new app, use your mobile device to sign in, and then the thinking is, if you use your mobile device to sign in on a new system, if that's your system, if that's not your friend, you can create a brand new passkey on that system that signs you into the account. So tomorrow, if you come back on your Windows machine, you don't have to grab your phone again because that would be painful, right? You can now just on your Windows machine, show your face, touch your fingerprint, whatever you need to do, and that gets you back into that same service in an easier way. So no need to fall back to using your phone every single time that you want to log on devices that you own and devices that you trust. So with this, let's look at a quick demo if I can make this work. This is always a little bit tricky, but I'm going to try my best. Let's open this guy up here. And essentially what I want to do is I want to show the experience that I just talked you guys through. I want to show that experience in real time on my Android device. So let's see if we're able to make this work. If everything works, you should see my phone screen there in a second. Cool. Okay, so that's always good if that part works. So that is just my Android phone that I have here, right? So I'm going to take you through a typical experience of a user here using passkeys. And essentially it goes like this. User goes, opens their browser, and they hit their favorite banking website. In this case, I have this fictitious bank called TriBank. I've never dealt with passkeys in my life ever before. This is my first time doing that. So what will happen is the system says, hey, do you want to sign in? ignore the sign in with a passkey button at the top for the moment. Let's just talk about the or space at the bottom, right? So this is a user never dealt with passkeys ever before, first time ever. They're going to go in, they're going to type, let's refresh this, make sure everything works. Yep, user goes, types username, types password, and hit the sign in button, right? Now what will happen in the background is the system will detect, the TriBank server-side system will detect I'm on a device that supports passkeys. That's a silent detection mechanism we've added. And it'll offer the user the option to create what's called a passkey. So there's an explicit passkey creation moment that takes place. I'm going to say, yep, create me a passkey. System UI kicks in and says, hey, do you want a passkey? I say, yeah, sure, I want one. Here's a little bit of metadata about the passkey. Passkeys contains an icon, it contains a display name, it contains a username, a bunch of information, and it also tells me there down at the bottom that this passkey will be synchronized to my Google account in the future. So if I sign in to Android on any other device, I will actually be getting those passkeys on that device as well. And then lastly, I need to do a user gesture here, touch my fingerprint, and that creates me a passkey. So now that I have a passkey on my phone, next time I come back to TriBank, either on this phone or on any other phone that's signed into that same Google account, all I have to do is either now know that I have to hit the sign in with a passkey button, but we know most users won't. So we've decided to also integrate passkeys with the autofill system on the particular device that we're on. So if the user were to click into the account name field here, which is what I'm going to do, rather than allowing me to type, it'll come up and say, hey, you've got a passkey. Do you want to use that? And I'm going to go, yeah, sure. I want to use my passkey. Click it, touch my fingerprint. And at this point, I should instantaneously be signed into the account. Now, I mean, up until this point, that still makes a lot of sense. One other cool thing that I didn't say is, once I made a passkey on the web, the same passkey is also usable in an app. So if I download the TriBank app from the Google Play Store, I can now open the TriBank app. I can hit sign in with a passkey here. I can click on that exact same passkey I created over on the web. And because the app and the website is linked using asset linking, I can go and just touch my fingerprint and amazingly be signed into my app as well. So whether I create the passkey on the web or the app doesn't really matter. They're usable in both places. And then as a last kind of little add-on to the demo is, let's quickly show how the experience would work for a user that's on a friend's machine. So I want to sign into TriBank on my buddy's machine over here. And what I'm going to do is I'm going to go to the TriBank website. Let's make sure it's online. There we go. And I'm not going to type in my username and my password here. I'm simply going to say sign in with a passkey. The system will detect that I don't have any passkeys yet for TriBank, so it's going to tell me to scan this QR code. Now, the QR code is necessary just to let these two devices know that they want to be talking to one another. If you have another 5 laptops and 2 phones in the audience here, we don't want my phone to accidentally talk to your laptop. So it's kind of like a disambiguation thing where I want to make sure this laptop and this phone talk to one another over Bluetooth. I'm going to say use passkey. There is no explicit pairing. Everything is handled by the protocol. So I say, yep, I allow these devices to talk to one another. The passkey I created earlier in my demo is now available on my phone. I pick it, touch my fingerprint, and at that point in time, I should be magically signed in on my laptop here on the left. And as I said earlier, because I don't have a passkey on my laptop yet, the website will offer me to create a local one. So next time I come back to TriBank, I don't have to grab my phone. So I'm going to say, yeah, sure, make me another passkey on my laptop. I can use my fingerprint because this laptop is one of those that's equipped with a fingerprint sensor. So I'm going to touch my fingerprint. And now I have yet another passkey for this website on my laptop. So if I ever come back to this website on my laptop here, I can just click sign in with a passkey, touch my fingerprint, no phone needed, pick the credential that I want to use, and instantly I will be signed into the account. I promise I'm almost done. We'll go a quick recap, and then I will make time for the panel here. Let's just look at a quick recap here. So what did we see here? Well, the first one is user info is stored on the authenticator on the registration, right? Remember I had this promo where the website said, hey, do you want a passkey? At that point in time, I create the credential on the device. It's called a discoverable credential, which means metadata about the credential is associated with it on the device, which means I don't need to type usernames anymore. I don't need to type passwords. All of that information is now associated and stored on the particular authenticator on the platform. So next time I open that website up, the system can prompt me for all of my stored credentials. I simply pick the one I want to use, click on the one, do my fingerprint scan, and amazingly, I'm signed in. As I said, the synchronization happens if I own more than one device and they're all signed into the same account. We get synchronization. Now here's the little caveat. Synchronization doesn't happen like in password managers between Chrome on Windows to Chrome on Android to Chrome on Mac. No. For FIDO, we want low-level platform support. So passkeys only sync in between ecosystems owned by the same vendor. So on Android, my passkeys made on Android only sync to other Android devices. It doesn't sync anywhere else. Passkeys made on macOS sync to iPadOS, and they sync to iOS, all part of the Apple ecosystem. Passkeys from Android does not sync to iOS. If I want to sign in on my Mac device using an Android phone, I need to use the cross-device Bluetooth flow that we saw, the QR code scan flow. That's how I get my passkeys, or the sign-in mechanism between devices of different ecosystems. And the reason why we went for that is we wanted the security properties of hardware-bound and stored keys that's stored directly inside of the system. We did not want to have the same issues where the private keys is perhaps just stored in a file on disk, so malware can get to it. We wanted the assurance of having these keys protected by the hardware, which means passkeys also inherently get away from other forms of multi-factor. If I have a passkey, I don't need SMS OTP. I don't need Google Authenticator. I don't need push authentication. Passkeys solve two authentication factors in one single step. The possession of the key and the way to unlock it is enough to get access to a passkey, which should then account for both authentication factors in one fell swoop. That's the other reason we wanted to go down the passkey route here with the protection. Last slide, I promise, is, and then of course the integration with Autofill. We don't think it's going to be successful if we have to train users to go and find a button like this on a page. So we actually don't think that a button like this should even be on a page for the next 5 years. We should have integration of passkeys directly in the autofill system so that together with your passwords, we just show you available passkeys, you click on it, and you can sign in. And if you don't have a passkey available, you can always go passkey from a different device, which allows you to pair a different phone, bring it to this in proximity, and then use the passkey from another device to sign in on the device that you currently own and that you're currently on. That is it. I know I am 1 minute over. Any questions? I guess we can get into lots of questions afterwards.
Thank you, Christian.
All right.
I do know I have tons of questions, but that's why we are doing the panel now. So Andrew and Tim can also come up and join me on stage. Well, short round of applause for Christian first, of course.